Let's talk about the graph terminologies in this video. Before that, let me tell you what is a graph and how a graph will look like, right? So a graph is nothing but a non-linear data structure, of course, a non-linear data structure, and a graph has nodes, are also called as vertices sometimes, and edges. Okay, the nodes are connected with the help of edges, right? So that's how a graph works. So if you denote a graph by G, and if you denote the vertices by V and edges by E, then you can say that graph is a collection of vertices and edges. Okay, so that's how a graph works. Let's see some simple structures of graph. It may look like anything. Okay, you can even connect any two nodes. It's not like a tree. Let's say this is my graph, right? This can be a graph. It may or may not form a loop. Okay, it is not necessary that it should always form a loop. It may or may not, right? Okay, so this may be a graph. If I put like this is also a graph, right? And there may be connection from A to E also. C to E, this is also a graph. So uh, there may be edges or links or connections between any two nodes. Okay, and the number of connections are infinite, so this is called a graph. Okay, we can even have connections from A to C, doesn't matter. So you can have a lot of connections, so it is called a graph, right? Okay, so okay, let me explain this. Let me explain the basic terminology. The first terminology is undirected graph. Undirected graph. It is self-descriptive. The name itself explains to you what is undirected graph. Let's take a graph. Okay, B to C and D. Right. This graph is a simple graph. Okay, so this is an undirected graph. Okay, this is definitely an undirected graph. Why? Because you can see that this graph doesn't have any direction. Okay, so from A to B, this edge means that, what is the meaning of this edge. Okay, this connects A to B, or I can also say B to A. Okay, it is bidirectional, so which means that this edge doesn't contain any direction. Likewise, this and this, they don't have any direction. Either I can go from D to A or A to D, right? They don't have any direction, so that's what we mean by undirected graph. Okay, what is directed graph then? Directed graph, what is that? That is just opposite to this undirected graph. I'll take the same example where I would have some directions like this. Okay, then that is called as directed graph. Okay, so you can move only from A to B, and from B you can move only to C. Okay, from C you cannot move to B. Okay, you cannot go back. Okay, because it is a directed graph. Okay, and from C you can move to D. Okay, okay, that's all for directed and undirected graph. Third one. So the third terminology is weighted graph. Okay, weighted graph. So what do you mean by weighted graph? Let me take an explain. Example. Oh my God, just hold on. Colors are different, right? Hope it's recording. Yes. Right. So let me explain weighted graph. Okay, so let me have this graph. Let me stick with that graph. Okay, A B C D, right? And let's say if you don't mention any number in between the edges, okay, in between the nodes, if you don't mention any number, it is assumed that the graph's weight is 1. Okay, the weight of each edge is 1. All right, and that becomes an unweighted graph. Okay, because the weight is by default 1, so that becomes an unweighted graph. Otherwise you can give weights like this. So you can give 2 for this edge, you can give 5, you can give 7, you can give any number, okay. So which means that the weight of this edge is 5, okay. It is not 1 now, it is 5 because it is weighted graph, right? And the weight of this edge is 2, the weight of this edge is 3, okay. So you can have weighted graph like that, all right. So yes, so if I put the weight of A to B, that become 2, okay. So you can give any numbers, guys. So this is all for a weighted graph, okay. That's it. And unweighted graph means the examples that we have seen here, both are unweighted graph because we don't have any weights, so we automatically assume that all the weights are 1. So this is unweighted graph, all right. Let me go for the fourth example. The fourth example, I mean the fourth tree terminology is in degree and out degree. Okay, I think we have seen this concept degree in trees itself. So in graph also it works in a very similar way. But anyway, let me explain that. Okay, let me have A, B, C, D, right? All right. So you should have directions. Okay, let me say that like this. Okay, so let me first mention all the nodes. Okay, so I should call it as vertices or nodes, both are correct. And let me write the in degree and let me write the out degree also. Okay, super, right? And yeah, vertices, say I have 4 vertices, so A, B, C, D. In degree is the number of you know, in degree is nothing but the number of degrees that are incident on a particular vertex, I could say, that are falling on the particular node. I mean that is coming inwards to the particular node, okay. And I told you it will work only for directed graphs. Undirected graph also you can write, but it doesn't matter, right? The number of degree is nothing but the number of edges that are incident on a particular vertex, guys. The number of edges that are incident on a particular vertex. So I'm talking about A here, right? On a vertex A, there is only one vertex which is coming inward, okay, which is coming towards A. Okay, I could also say towards, okay, towards, okay. So there is only one vertex, so the in degree is 1, all right. Out degree is nothing but number of you know, number of edges that are going outwards, okay. So this is away or outwards. So one goes away, one arrow mark goes away here, so out degree is also 1 for A. For B, both arrow marks are going away, okay, both edges are going away, they are not incident. So in degree is 0, out degree is 2, because there is nothing which comes inside B, okay, there is nothing. Both the edges are going outside, okay, both are going outside, you can clearly see that here, both are going outside. So in degree is 0 because there is nothing coming inside, and both are going outside, so out degree is 2, right? And for C, if you consider one is coming inside and another one is going outside, so in degree is 1, out degree is 1. For D, if you see, both are coming inside, nothing is going outside, both are coming inside towards D. Okay, so towards means in degree. So in degree is 2, out degree is 0 for D. So that's how in degree and out degree works. Okay, yes. Fifth concept is a loop. Okay, again it's self-descriptive. Let me explain this quickly. Okay, so let me say I have a graph like this. Okay, super. So what is a loop? Okay, so please you know, follow me here. This is something crucial. Okay, let's say this edge, let's consider this edge, okay. This is an edge, right? So what is the starting point of this edge? Let us name this edge, say first edge, okay. So what is the starting point of this edge? That is A, okay. Starting point is A. Okay, let me have directed graph so it will not confuse you. Hold on. Right, So let me consider this edge, this green color one. All right, this edge. Okay, the starting point is A and the ending point is B for this particular edge, right? So for that particular edge, the starting point is A and the ending point is B. Starting node is A, ending node is B. That is an edge here. Okay, super. For this edge, the starting point is B and the ending point is D for this particular edge. Okay. Similarly, if you consider this one, okay, I think I could take another color. Yeah, if you consider this edge, okay, follow me, this edge, the starting point is C, the ending point is also C, right? The starting point is C, the ending point is also C, and that edge is called as a loop. Okay, loop is nothing but an edge. A loop is nothing but an edge which has same starting node and ending node. Example in this case C. Okay, it has a loop, right? So that's it. Same starting node and an ending node, same ending node, right? Or I could say the ending node and starting node are one and the same, right? So that's the loop. The sixth terminology is path. I think I have explained this path. Okay, let me take the same example and explain path. Okay, I've already explained this in tree, right? It works in a similar manner here, right? This is E. Then let's take it O. This is E, and okay, E is there, right? So what I can do here is P and that's right. So if I ask you, this is a graph, okay, undirected graph, undirected graph. Let me ask you a quick question. Can you please tell me what are the paths paths between possible paths between A and D? Okay, and you have to start from A, you have to go up to D. What are the possible paths? Okay, and the first possible path is I can start from A, I can go to O, I can go to P, and I can reach D. Right? I can reach D. That's one possible path. A to O, O to P, and P to D. Right? So that's one possible path. Or else I can start from A, I can go to B, and I can go to D. Right? 1 and 2. Right? So that's another possible path. And or else I can start from A, go to C, go to E, and reach D. Right? So C, E, and D. So there are three possible way. One path, second path, and third path. So there are three possible paths to reach to D from A. Okay, there are three possible paths. The shortest path is ABD, and the longest path, the position of longest path is shared by these two. Right, so these two are both the longest. Right. Okay, so this is undirected graph. So yeah, that's all about path. Okay, you can always determine path between any two nodes. Okay, the path between any two nodes can be more than one. Okay, it need not be one. Okay, you can see it is three paths between A and D. Seventh one is a cycle. Okay, cycle formation is something easy to explain. Okay, pause the video and make a guess. What are the nodes that form a cycle? Okay, in this particular graph, this is a graph. Okay, and if I talk about the nodes, I can say nodes. This node, and this node, they form a cycle. Okay, so this is called a cycle. Okay, 1, 2, 7. So this is called a cycle. Just because you can start from any node to reach any other node in this cycle. Okay, if you start from 1, you can also reach 2 and 7. If you start from 7, you can even reach 1 and 2. If you start from 2, you can reach 1 and 7. Okay, so if you start from any node, you can always traverse the whole cycle. That's why it is called a cycle. Okay, cycle, right? And the next terminology is articulation point. or cut point. Okay, articulation point or cut point. All right. So let me take a graph. 20, 20, 30. This is also a graph, guys. You can have any structure you want, right? Okay, fine. The articulation point is a particular node. If you remove that node, if you cut that node, the graph will be disconnected. The whole graph will be disconnected, or the whole graph will be disturbed if you cut that one node. For example, if I cut 50, nothing will happen to this graph, right? This graph will remain the same. But if I cut the node which acts as an articulation point, then the graph will be totally disturbed or disconnected. Can you guess which is the articulation point of this graph? Just pause the video and guess which is the articulation point of this graph. Yeah, I hope you have got it. The articulation point for this graph is this 30 and 40. Okay, because if you remove 30, it will separate the graph into two pieces. Okay, this will be one graph and this will be another graph. So that's definitely an articulation point. Okay, and if you remove 40, it automatically removes 52. Okay, it will remove the 50 also, but we don't want that, right? Okay, if removal of one nodes removes any other node means that is an articulation point. I could define it in that way also. If removal of one node influences the other one, I mean removes other one also, which means that that node is an articulation point. So 30 and 40 are articulation points here. Okay, if you remove 30, automatically 40 and 50 will be disconnected, and if you remove 40, 50 will be disconnected. So if any node is getting disconnected, means that is an articulation point. Okay, I hope you understood this. Let me go to the next one. The ninth concept here is connected graph. Okay, it's very simple. Very simple. Connected graph may look like this. This is a connected graph. The traditional definition is between any two nodes, there is an edge, there is a connection, or there is a link. That's how we can define the connected graph. And see, this is the connected graph. Okay, from A to C you have a connection, from A to B you have a connection, A to D you have a connection, C to D. Okay, for between any two nodes you are having a connection. That's why it's called connected graph. This is not a connected graph, guys. People would confuse that this is not a connected graph. This may look like connected graph, but it is not connected. Why? Because you can see that there is no connection between A and C directly, right? There is no connection between A and C directly, so this is an unconnected graph or disconnected graph, right? Yeah, okay, that's how it goes. I think those are all the terminologies I wish to explain. Let me explain a lot on the next video, some other concepts, right? Thanks a lot.